Welcome back. Let's take a look at section 10.6, segment relationships in circles. So now we're going to look primarily inside the circle. If we take a look at some of these terms right here, we have segments of a chord. And so if I already have right here a diagram, and I've got two chords, one that's in like light blue, the other one that's in red. And so hopefully you see that there are now going to be four segments. We're going to look at some of those segments inside of the in this section. Next up right here we have a tangent segment, and I'm going to go ahead and in our diagram show you that our tangent segment happens to be on the outside. Okay, and remember, something that's tangent only intersects the circle once or touches the circle at one point. And so in red right here, that would be your tangent segment. And what we also see here is I have something highlighted in a neon green for you. And this right here, we'll go ahead and label that your secant segment. And then the one that's highlighted right here in purple, this section, that's your external segment. All right, so we've got three main segments or parts that we're going to look at in a diagram that looks like this, and when we take a look at it in our problems today. Go ahead, moving along, let's take a look at this theorem. Theorem 10.18, segments of chords theorem. So I told you we're going to look at something in relation to that first diagram, and here it is. It says if two chords intersect in the same, in the interior of a circle, then the product of the length of the segments of one chord is equal to the product of the lengths of the other chord. So if I take right here EA, I'm going to go ahead and highlight that. EA times EB, okay, I'm highlighting that in red. That is equal to, right here, EC times ED, which right here I'll highlight and underline with blue. So those two chords right there, you put them all together, take the product of the segments on the same chord, and that's equal to the product of the segments of the second chord. The big thing to this one right here, we already kind of talked about this diagram, but tangent segments and secant segments, making sure you know all of that right there. Okay, and I already showed it to you just a few moments ago, but if you want to take a look at this, it's pretty much the same exact thing. Just make sure you know your parts. So in Theorem 10.19, we have segments of secant theorem. And what they're saying right here is this. If two secant segments share the same endpoint outside a circle, then the product of the lengths of one secant segment and its external segment equal the product of the lengths of the other. So here's the important piece right here. That they're saying is that if I take EA, okay, and I multiply that by the entire segment, E to B, that is equal to, right here, the external segment, EC, times the secant segment, E to D, right there. Just like that, okay? So external segment times the secant segment is equal to the exterior segment of the other secant segment as well. All right. In Theorem 10.20, okay, this one is a little tricky. Segments of secants and tangents theorem. In this one, they're saying if a secant segment and a tangent segment share the same endpoint, and they do, point E, it's outside the circle, then the product of the lengths of the secant segment and its external segment equal the square of the length of the tangent segment. So right here, the tangent segment is E to A. Okay, so you take that tangent segment and u squared. That's what they're showing you right here, and I just underlined it in the equation. That is equal to the external segment of the secant, which is e to c. I'll underline that now in blue. And then times the secant segment right here of e to d in the diagram, and also in the equation, I'll highlight that in green. All right, so making sure you understand that equation along with 10.19 will take you a long way in finding our answer to these problems. All right, so now we can go ahead and solve some of these questions here. So in number one, I've got two chords and I've got segments. Okay, if we remember our theorem, it says if I take one segment right here, or one chord, I've got 6 and 5. I take the product of those two and I multiply right here the other segment of the other chord, x and x plus 1. So let's go ahead. I want to go ahead and set up my equation. So x times x plus 1, that right there is equal to, in blue, we got 6 times 5. And let's just go ahead and put parentheses instead of the dot. Okay, so what we're going to do is go ahead and solve this out. Let's take that x, we'll distribute that, and I got x squared plus x, and that's equal to 30. And right here, we have ourselves, hopefully you know what type of function this is. It has x squared, it's a quadratic function. So we're going to go ahead and, we got to set this equal to 0. And so we're going to subtract 30 to both sides, and now we have our trinomial. And so when we get to this trinomial, there's always 3 ways to answer it. You learned it in Algebra 1. You have complete the square, which you probably don't like. You've got the quadratic formula, which is that long equation that you learned. And then you also can factor. And oftentimes you can factor out these problems. And so let's see if we can factor this. Now, what are factors of negative 30 that add up to the middle term, which has a coefficient of 1? All right. So what are factors of 30 that add up to 1? Okay, so I kind of set this up right here just in case to maybe help you remember what exactly am I doing right here. And so there's only one set of one combination that works, and it's going to be 6 and negative 5. This right here, these two multiply to 30, they add up to positive 1. So what do I do with this? I got x plus 6 as one of my binomials. The other one is x minus 5. And set that equal to 0. All right, so x plus 6 equals 0. X is equal to negative 6. We got x minus 5 equal to 0. X is equal to 5. And I try to show you all the steps right here, make sure they work out, and to show you what I'm doing. Now, we come to this crossroad. We got 2 answers. You think you're done. The only problem is in this question, I have one of my answers as negative 6. And if I were to like plug in negative 6 right here where the x is, does that make sense that we have a segment that's negative 6? It does not. All right. And if you were to plug in negative 6 right there, it just, we got negative 6. It just doesn't make sense. All right, so therefore, we will call that an extraneous solution, and my only answer that will work out is x is equal to 5. All right, and there you go. Let's go ahead and take a look at number 2. Okay, we're pretty much the same idea right here. We got 15, we've got 5x minus 2. So we got 15 times 5x minus 2. There's one segment of chords that's equal to the other one, which is 10 times 7x. All right, so let's go ahead. We got 15 times 5x, that's a 75x, minus 30 is equal to 70x. Luckily, this one we don't have an exponent, so we can just go ahead and get x by itself. I want to subtract 75x to both sides. And looks like I'm going to have negative 5x. And then when I divide both sides by negative 5, it works out nicely where I have now a positive answer of 6. Plug it in, make sure it works. I'll tell you already it does on this one. But it's always good habit and good practice to double check. All right, now we've got two types of problems right here. Number 3. Hopefully you see that we have, in this one, we've got two secants, okay? So we're going to take a look at number 3. Right here, there are two secants. It might be a little bit difficult when you're taking a look right there at where that 1 is, but that happens to be a secant, okay? So remember, how this problem goes, if you go back and take a look at Theorem 10.19, is you take the external. Okay, so we're going to take, I want to highlight that right here. Take the external segment. Let's set this up. I've got x plus 2, and I want to multiply that by the internal. Or sorry, the whole entire thing right here. Now, the entire thing is 2 parts. So I want to go ahead and put this as x plus 2 plus 1. Okay, so that's going to represent the entire segment. And let's set this equal to the external segment of the other side of the other secant, which is 2. And then we're going to multiply that by the entire segment, or the secant right here, which is going to be x plus 3 plus 2. And let's just go ahead. We'll begin to simplify things out first. So I got x plus 2, and then we got x times x plus 3, and that's equal to 2 times x plus 5. All right. So we have that right there. Let's see what we can do. On the left side, what can you do? There is no whole lot except to multiply, and you got to FOIL this out. So let's go ahead right here. I'm going to FOIL this. First, outer, inner, last. X times x is x squared. The outer, that's going to be plus 3x. The inner, plus 2x. And then the last is plus 6. Over here on the other side, we have that equal to 2x plus 10. And I just need to distribute over there. So typically when we have a quadratic, and why is this a quadratic? Because we've got x squared, we got to set things equal to 0. Okay, so I'm going to go ahead and begin to simplify this out. And then now let's go ahead and move everything to one side. So I'll subtract 2x to both sides, and I get plus 3x. I'll subtract 10 to both sides, and I now end up with minus 4. So just like in the last question, now we're at the point where we need to factor or use the quadratic formula or complete the square. Once again, probably using the factoring method is probably the best. So we got x times negative 4 are factors of the c term that add up to the b term. That's what this is supposed to represent. So what are factors of negative 4? Let me go ahead and we have 4 and negative 1. Why do I choose this combination? Because 4 times negative 1 is negative 4. 4 minus 1 is 3. So right here we have, oops, keep pressing button on my keyboard here. So we got x plus 4 and x minus 1 set equal to 0. So I'll go ahead and solve this out real quick. And we got negative 4 and 1 as both of our numbers. So once again, if you plug things in right here, like up where x is, it doesn't make sense that we have a segment like 4 plus -4 plus 2, that's -2. Does that make sense as a segment? It does not. So therefore, right here, we only have one right answer, and that is going to be 1. Okay? So that right there, 2 secants. That only means that what's left right here in number 4 is when we have a secant and a tangent. All right? So if you go back and take a look at Theorem 10.20, it says, if you have a tangent segment, so we're going to go ahead and worry about that tangent right here, the x plus 1, you take that tangent, you square it. That's going to be equal to the external segment. I want to go ahead and put that as x minus 1 times the secant segment, which will be the whole thing right here. And I'm going to put that as x minus 1 plus 5. Okay, so just showing you, okay, that we added all the parts up right there to get that. And so let me put that right up above it, actually. And so right here, down below, I'll go ahead and put the simplified version of that being x plus 4. So we've got a whole lot of things going on. We've got to just solve it out. On the left side, okay, don't make the mistake of saying that that's x squared plus x. Okay, that is incorrect. Because if you were to expand this out, it's x plus 1 times x plus 1. If we FOIL that out, we get x squared plus x, and then plus 1. Right? First, outer, inner, last. Guess what? It's not x squared plus 1. It's x squared plus 2x plus 1. Okay? So there is that right there. On the right-hand side, we FOIL this one out. We got x times x is x squared. X times 4 is plus 4x. The inner, minus x, last, minus 4. All right? And so we go ahead. I'll simplify this out. Go ahead and bring that down. And so right here, we can go ahead and try solving this out. We'll set this equal to 0. But luckily, hey, if I subtract x squared to both sides, hey, the x squares cancel. So then how about this? Let's go ahead and move the 3x to the other side. So I'll subtract that to both sides. And what I'm going to also do, just to kind of save space, is let's go ahead and subtract 1 to both sides. Okay, so 2x minus 3x, that right there gets us negative x. Got negative 4 minus 1, that's going to get us negative 5. So in the end, let's divide both sides, don't forget, by negative 1. So we can get x to become positive, and x is equal to positive 5. And there you go. We went ahead, we solved this out, we look good. We found the answer. All right. If I helped you out right here and you learned something, appreciate it. Make sure you give me a follow or subscribe, like the video. Hey, and I'll answer any of your questions in the comments. Thank you. Have a great day.